Hello, welcome everyone to question number 11, height of binary tree from the topic trees. In Geek for Geeks must do interview questions. Just have a quick look at the question. I will be discussing the meaning and the approach to the question. Before that, please don't forget to hit the subscribe button. If you have any doubts, just leave a comment below. We'll be very quick to respond. And if you have any extra email IDs, please do subscribe with those. That will be very helpful for the growth of the channel. Now let's go into the understanding and approach of the question. Here we have a tree. Now the question is saying we have to find the height of this tree. Now we have to know what is the height first. The height is the longest path from root to leaf. For example, in this tree, you can see the longest part could be 127, or it could be 126, or it could be 134. Here we have three parts to compare. Okay, but visualizingly, you can know already the height of this tree will be 3 here because 1, 2, 3. Okay, there are three elements here, right? 1, 2, 3. So that is the longest path, and that will be our height of the tree here. Okay, now how can we do it using the coding part? Okay, now this for basic understanding. I hope you have understood what is the meaning of height of binary tree. Now coming to the coding part here. Now coming to the approach, we have to take the maximum of right subtree and left subtree. Okay, in this question, if you see the left subtree, we have total 3 elements, that is a max, and right subtree we have 3 elements, that is also max. So out of 3 and 3, the max element is 3 itself. So you can take left or right also, there is no problem. And but we have to do this in step by step manner. Now how we do that in step by step manner is we take a function and we use it as a recursion. In that we'll be taking left subtree and right subtree, and we'll be digging one by one. Okay, now if we use recursion from root here, it will call left subtree. Okay, then that left subtree also we have left and right subtrees. Okay, now we will focus on only left subtree for now. For now, if we focus on left subtree, this one will call this two element, then this at this present state it will call the next child here in the recursion function. Now at this 7 point, there is no child here, there is no leaf node, or there is no child node here. So it will stop here, and what will it do is it will get 1 as an output. Okay, since there is no element below, we will take 1 as the output here. Now similarly, for the next left subtree, we will take 1 as an output. But remember, if there is no element below, then that will be considered as 0. Here we have no element below here. So 1 plus 0 is 1 here. But in the second element case, the child element already has the value 1 here. Okay, now this 1 will be stored and plus 1 will be added. So 2 will be coming here. Similarly, for the root element, child element value will be 2, and 1 plus 1 element, child element has 2 value here, and the root element will add 1 again here. So 2 plus 1, which will be 3 here. So that's how we got the 3 value for the left subtree here. And similarly for the right subtree, if the leaf node, there is no leaf node, that will be treated as 0. Okay, now for the current element, it will be treated as plus 1 here, 1 and 0 here. Okay, now that is fine here, 1 and 0, we got 1 value here. And similarly plus 1 will be added, we get 2, and at last we get 3 other sub value. Now what about the remaining nodes here? For 6 node, it will follow the same. For 6 node, it is 0 and it is 1 here. Now it will compare between left subtree and right subtree. What is the maximum value here? The maximum value for left subtree and right subtree is 1 here. So there is no issue. It will get 1 value. Okay, and it will add a plus 1 to that. That's how we got 2 here. And 2 plus 1 is 3. Okay, for the root element, left subtree we have 3 value as the max, and right subtree is 3 value as a max, and out of those both we choose the maximum element, which is 3 here. Similarly for the 3 value here, we can see we don't have any left subtree here. So left subtree value is 0 here. Okay, but right subtree value is 1 here. Out of 0 and 1, 1 is the max here, 1 is max, so it will take 1 and add plus 1 to it. So that's how we get 2 value here for the 3 element. Okay, similarly we compare left and right element, and we get the maximum value of that. Okay, we get the maximum value and plus 1 of that. So that will give us the height of the binary tree. Okay, if we haven't understood, let's go into the coding section. I hope after seeing the code, every doubt you have will be cleared. Now we are inside the coding section part here, and as you can see, we are using the recursion here. Okay, while we are using recursion, it will start from the deepest part. Okay, the deepest part of the tree will be the leaf elements, right? It will go to the last leaf. Okay, the last leaf element will start this function. Okay, then the later one, ancestor, the ancestor of the child will execute this function. Similarly, the ancestor of that element will execute. So starting with the leaf here, we'll go to the last element here. Okay, left equal to self height root dot left. So for the, if the root dot left is empty, in that case we're returning 0 here, right? We return 0 inside the max function. Now left is 0 and right can be anything. It can be 0 or it can be 1 or 2 also. Out of the left subtree and right subtree, we choose the maximum element. For now you assume we left is 1, right is 0. So we got 1 from the left, okay? So which is the max element. Now we're adding plus 1 to it. So we get plus 2 is like this, okay? And that plus 2 will be returned to this variable, and in this way left and right max values have been replaced every time we use recursion. Okay, at each element left and right max values are being replaced here. So when we reach to the root element and the function will be wholly executed, then we will choose between maximum of left and maximum of right, and we add the plus 1 there. Then we get the height of the binary tree then. I hope you have understood the presentation and the code. If you still have it understood, just leave a comment below where we can improve this. And if you have any extra email IDs, please don't forget to subscribe our channel. That will be big support and growth towards our channel. Okay, and thank you for watching till then. Let's meet in another question.